Hi, this is Sree from Techie Talks AI. In this short video, we'll see how embeddings or vectors work and then how they're used to find similarity. A retrieval-augmented generation uses this chunking mechanism to efficiently identify relevant chunks when we query large language models. With the help of this video, we can make the basics very clear. First, what we're going to do is we have hard-coded a set of 4 words. They will represent our chunks. Okay. Normally, in RAG applications, we will have a large amount of local data. It could be PDF files, it could be website URLs, etc. And we read them and then convert them into smaller units, maybe a couple of sentences or a paragraph. But for us to understand how these chunks work, we are using 4 words. Okay. So let's run this and see what happens. We are using Gemini's text embedding model. We got some numbers as output. What are these numbers? For each word, say for dog, swim, water, bark, for each of these words, we have a set of numbers. They're actually like X and Y coordinates in a 2-dimensional space. I have deliberately used 2 dimensions for this embedding. Normally, when it comes to OpenAI, it can go something like 1536 values for each embedding. So these values together will represent that chunk in a hyperspace, indicating its meaning. That is, chunks with similar meaning will be closer. Okay, so that is what we are going to highlight. So the reason why we have selected a dimension of 2 is to be able to easily visualize. Okay, so let's move on. So we have got these chunks and we have got the corresponding embeddings or vectors. So far is clear. Now what we are going to do is we are going to draw this. So I have a small snippet of matplotlib which will draw these chunks in a 2-dimensional space, because our chunks are encoded into a 2-dimensional space. Okay, so you will notice that we have dog here, bark, water, swim. They're relatively placed next to each other because they have similar meaning. Okay, so remember, we are using just 2 dimensions. Normally, it will have 1536 dimensions, which we cannot visualize. So far is clear. We have the chunks and we have the corresponding embeddings or vectors, and then we have drawn them into a 2-dimensional space. Normally, we don't need to draw it. This is just to show you how it works. Okay, so let's move on. Now what we're going to do is we are going to find the embedding for the query that we want to use. So here we will use sleep as our query. Now the word that we want to query also has to be converted into an embedding or vector. Then only we can apply the similarity search. So what we are going to do is we are going to apply the same text embedding model of Gemini and same dimensions we will use so that we get X and Y coordinates for this query text. So let's run it. Okay, so we got 2 numbers. Now what we will do is we will visualize this sleep word also on the same graph so that we will know how they look. Okay, so here I have drawn, see this one, sleep is placed closer to dog, okay, and away from swim and water. Is that clear? So now let's see how it works. If you want to find out the distance between this word to other words, there are different mechanisms available for us. Okay, so one is a cosine similarity. There are vector database providers and they provide the similarity search mechanism also using the index in their database. But in our case, we will use simple cosine similarity. So what we will do is, we have a function here, retrieve relevant chunks. And what should be the input parameters? The query's embedding coordinates, full embedding all the chunks. And it also needs the chunks. Clear? So this is X and Y of our query. This is X and Y for all our chunks. Okay. Now the goal of this function is to find out the closest embeddings. So here, if you see, we are calculating the cosine similarity. That is a mechanism, established mechanism. There are other mechanisms like dot product, which we will see in other videos. We will find the similarity, then we will sort the similarities and retrieve two chunks from it. So here we will convert them into chunks from the chunks list. So that is what it is, and then it will join them as a string and return it. So essentially what we will get as a result of calling this function is closest chunks. In this case, two chunks. So let's run it. So see here, we got bark and dog when we search for sleep. So sleep is closer to dog than swim and water. So we got, when we search for sleep, we got dog and bark. This is what I wanted to highlight in this video. Let's move on. We will go into advanced RAG mechanism in subsequent videos. And remember, let's learn step by step, going deep into all these aspects. Please remember to like, share and subscribe, and give your valuable comments and ideas. So let's learn together. This is Sree signing off. Bye bye.